Good evening. In today's class, I am going to explain you some more problems given in previous Jeemain from the chapter System of Particles. In particular, based on the topics center of mass, torque and angular momentum. Let's move on to the problems. We have already completed some problems till yesterday's class. So, we are going to see the remaining problems. Look here, a particle of mass 100 grams. So, mass of the body given here is 100 grams, right? It is projected with a speed 20 meter per second at t is equal to 0. So, initial speed with which the body is projected into air is 20 meter per second, projected at an angle 45 degrees to the horizontal. Theta is equal to 45 degrees. The magnitude of angular momentum of the particle at t is equal to 2 seconds is found to be. So, here this is a body projected into air obliquely. It takes a parabolic path. At any instant of time, let the particle be at this point. So, along this direction, velocity vector will be there, and horizontal component of velocity is given as Vx, vertical component of velocity is Vy. So, here and vertical displacement is taken as y, horizontal displacement at any instant of time t is taken as x here. So, let us do this problem carefully. See here, we know angular momentum is r bar cross p bar, where p bar is equal to m v bar. So, first we need to find out the position vector. So, r bar we have to find out. So, r bar is equal to x I bar plus y j bar. So, x is equal to, so r bar is equal to x is u cos theta into t, right, and y will be u sin theta t minus half gt square. So, here r bar is equal to u cos theta t I bar plus u sin theta t minus half gt square j bar. Let us substitute the values given. Initial velocity is given as 20 meter per second. So, this is 20 cos 45 1 by root 2 into t is given as 2 seconds into 2 I bar plus u sin theta 20 sin 45 is 1 by root 2 into t minus half g is 5, t square is 2 square j bar. So, here r bar is equal to, this gets cancelled root 2 times 20 root 2 I, this gets cancelled root 2 times plus 20 root 2 j minus 5 fourths, 2 square is 4 minus 20 j. So, this is r bar, and next we need to find out velocity vector. So, velocity vector is v bar is equal to the component of velocity along the horizontal remains constant throughout the journey. It is just u cos theta. So, u cos theta I bar. Y component at any instant t is u sin theta minus gt j bar. Substitute the values. V bar is equal to u cos theta is 1 by root 2 I bar plus u sin theta is u is 20 by root 2 minus 10 into 2 j bar. So, this becomes 10 root 2 I bar plus 10 root 2 j bar minus 20 j bar. Okay. So, we could find v bar. Okay. Momentum vector is m v bar. See here, mass is given as 100 grams, that is 0.1 kg. So from that, if you multiply this with 0.1, it is root 2 I bar plus root 2 j bar minus 2 j bar is momentum vector. So we could find out position vector and momentum vector. We are supposed to find the torque. So what is the expression for the torque? Torque is equal to R bar cross F bar. So here we have to do it very, very carefully. So I cross I0, I cross J, 20 root 2 into root 2, that is 20 into 2, 20 into 2, I cross J. See here, I cross J is K bar. So next one, 20 root 2 I minus 2j, I cross j is k, minus 40 root 2. So this is minus 40 root 2 k bar. Then next term, the multiplication with I is done. J cross I is minus k, 20 root 2 into root 2, 40. So that is minus 40 k bar. So this and this gets cancelled. Okay, what else is remaining? J cross I. Okay, so and minus 20j root 2 I. J cross I is k, minus of minus becomes plus 20 root 2 plus 20 root 2 k. This is the angle R cross P, that is angular momentum, not torque. See, angular momentum is supposed to find here. We are supposed to find angular momentum here. So angular momentum is R cross P. So this is here. So what do we get? Minus 40 root 2 plus 20 root 2. Angular momentum is minus 20 root 2 k. This is the answer we got, but they have given in some other way. Option is on the other page. Look here, it is given as root k kg meter per second square. So if you take the magnitude of L, if you take this into the square root, it becomes 20 square, that is 400 into 2, that is 800 under root. So it is given as it is a root k. So comparing these two, k value is 800. So here it is given in the problem in the next page, it is a root 2k where k is 800. That is the answer for the problem. So problem is the same concept. Angular momentum is R bar cross P bar. So R bar is position vector, P bar is momentum vector given by mv bar. Okay, so that is the answer for that problem. Move on to the next problem. A tube of length 50 centimeters is filled completely with an incompressible liquid of mass. Mass of the liquid is given as 250 grams, that is 0.25 kg. And mass 250 is closed at both ends. Length is given, length of the tube is given as 50 centimeters. It is filled with an incompressible liquid of 250 grams and it is closed at both ends. The tube is then rotated in a horizontal plane about one of its ends with uniform angular velocity omega is equal to x root f. Okay, if f is the force exerted by the liquid at the other end, find the value of x. Here let us assume this as a tube filled with an incompressible liquid. This is the axis of rotation. As this is filled with incompressible liquid, that behaves like a uniform rod. So here mass will be concentrated at the center. So here we can assume this as a massless rod with a mass m concentrated at the center, then radius will be length by 2. Okay, L by 2, and the centrifugal force acting on this end will be m r omega square. Mass is 250 grams. Length is 50 centimeters. Radius becomes 0.25. Omega is given as x root f, whole square is x square f. That is the centrifugal force acting on it. So, this f and this f gets cancelled. So, x square is equal to 1 by 0.25 into 0.25. X is equal to 1 by 0.25, or that implies x is equal to 4. This is the answer. So, x is equal to 4. Move on to the next problem. Look here. The distance of center of mass from end A of one dimensional rod having mass density kg per meter. Linear mass density of a rod is given as rho is equal to rho naught into 1 minus x square by L square. Okay, that is mass is in kg and length is in meters. Then distance of the center of mass, the value of alpha, where x is the distance from one end. Look here. So, the distance of center of mass of the rod from one end is taken as x, that is given by 3L by alpha. Linear mass density is given. You are supposed to find something that is alpha. See here, XCM formula is integral rho x dx divided by integral rho dx. If rho is the linear mass density of a rod. Now, let us substitute this here. So, this is rho naught 1 minus x square by L square x dx divided by rho naught into 1 minus x square by L square dx. So, this constant we can just cancel this. We have to integrate this within the limits 0 to L, because we want to find the center of mass distance from one end, that is from 0. Okay. So, if you integrate this, what do you get? X square, this is, let us write like this, x minus x cube by L square dx divided by 1 minus, look here, 1 minus x square by L square dx. Okay, limits are 0 to L. So, integral x is x square by 2, x cube is x to the power of 4 by 4 L square by integral dx is x square integral is x cube by 3 L square. If you substitute the limits 0 to L, this becomes L square by 2 minus L to the power of 4 by L square is L square by 4 by L minus L cube by L square is L by 3. So, is that clear so far? Now, let us simplify this. This becomes, implies x is equal to L square by 2 minus L square by 4 is L square by 4. L minus L by 3 is 2L by 3. So, here this is equal to 3L by 8. 1L gets cancelled, it is 3L by 8. But here in the problem, it is given 3L by alpha. We got it as x is equal to 3L by 8, but they gave it as x is equal to 3L by alpha. You are supposed to find the alpha value numerically. If you compare this, alpha is numerically equal to 8. Okay? Move on to the next problem. Look here. 3 identical spheres, each of mass m, are placed at the corners of a right angled triangle with mu, right angled triangle. See, this is the right angled triangle with mutually perpendicular sides equal to 3 meters each. 3 identical spheres of mass m each are placed at the 3 corners. Taking the point of intersection, this as the origin, magnitude of position vector of center of mass from the origin. Let us write the coordinates of the 3 particles taking this point as the origin. This becomes 0, 0, this becomes 3, 0, this becomes 0, 3. So, if you write the coordinates, it will be like this: m 0, 0, m 3, 0, m 0, 3, this one. So, here x coordinate of center of mass is m1 x1, m2 x2 plus m3 x3 by m1 plus m2, that is equal to 1. Y coordinate of center of mass is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3, that is equal to 1. So, center of mass coordinates are 1, 1, or it is represented as I bar plus j bar, but you are supposed to find the distance. So, it is square root of 1 square plus 1 square, it is root 2, but it is given as root x. So, in place of x we have 2. So, the value of x is 2 here. Okay, simple problem. Now, move on to the next problem. Position vector of 1 kg object is given, velocity is given, angular momentum. See here, angular momentum L is equal to R bar cross P bar. R bar is given as, what is R bar here? 3I minus J. Momentum vector is mv bar. Mass is given as 1 kg. So, it is momentum vector becomes 3j plus k. So, you have to copy it down carefully, 3i minus j, 3j plus k. So, you are supposed to find angular momentum magnitude. So, in the vector form, it is just r cross p. Let us take the cross product. I cross j is k, it is 9k. I cross k is minus j, so minus 3j. J cross j is 0, j cross k is I, so it is minus I. So, its magnitude becomes square root of 81 plus 3 3s are 9 plus 1. So, it is square root of 91. So, we got L is equal to, magnitude is 91, but they gave it as root x. On comparison, x is equal to 91. X is equal to 91, that is the numerical value. Now, next problem. Look here, a meter scale is balanced on a knife edge at its center. That implies it is a uniform meter scale. When 2 coins each of mass 10 grams are placed on the top, one on the top of the other at 10 centimeters division. This is a meter scale. Let this be the starting point and the center. This is 50 centimeters division. At 10 centimeters division, 2 coins of mass 10 gram each are placed. So, the weight of the coins, mass of the 2 coins together is 20, 20 g will be acting in the downward direction. Now, it is found to be balanced at 40 centimeters mark, when actually it is balanced at 50 centimeters, when there nothing is added to the scale, right? But when this 20 gram is suspended from it, or when 20 gram coins are placed on the top at 10 centimeters division, it is balanced at 40 centimeters division. So, it is placed on a knife edge at 40 centimeters. That knife edge applies a force on the scale in the upward direction. So, what is the weight of the scale? Weight of the scale will be acting at 50 centimeters, because initially he mentioned that without any load the scale is balanced on the knife edge at 50 centimeters division. So, its weight is hanging at 50 centimeters. Taking this as the reference point, this creates a moment in this direction, anti-clockwise, and this creates a moment about this point in the clockwise direction. So, as the scale is balanced, the clockwise moment should balance anti-clockwise moment. So, clockwise moment is W into its perpendicular distance from this point is 10. That is equal to anti-clockwise moment is 20, its distance is 40 minus 10, that is 30. So, here W is equal to 60 grams, that is the answer. So, the weight of the scale is 60 grams. Okay? Now, move on to the next problem. Look here, a particle of mass m is moving in time t on a trajectory given by this expression where alpha, beta are dimensional constants. Angular momentum of the particle becomes the same as it was at t is equal to 0. Then find the value of t. Okay, let us do this problem carefully. See here, position vector of a particle is given as 10 alpha t square I plus 5 beta t minus 25 j bar. Just I have separated that. 5 beta t j bar, 5 beta into 5, 25 beta into j bar, where alpha, beta are constants. This is r bar, right? Now, mass is given as m here and velocity vector. We find velocity vector by differentiating this. So, t square derivative is 2t. So, 20 alpha t I bar. T derivative is 1. So, 5 beta j bar. And there is no t term. So, this becomes equal to 0. This is v. Momentum becomes mv. So, this multiplied by m. Now, r bar cross p bar is equal to, look here, I cross I is 0, I cross j is k. So, 10 alpha t square into 5 beta. I cross j is k bar. So, this becomes 10 5s are 50 alpha beta t square. 50 alpha beta t square k bar. Now, multiplying this, j cross I is minus k. So, minus 5 into 20, 100. Alpha beta t square. Alpha beta t square. J cross I is minus k bar. So, minus k bar. Next, j cross j is 0, j cross I is k, minus j cross I is minus k, minus of minus becomes plus k. So, this becomes plus k. 25 into 20. 25 into 20 is 500. 500 alpha beta t. Alpha beta t. Is it okay? So, we found r cross p here. So, this multiplied by mass. So, actually whole thing multiplied by mass gives us angular momentum. This is the angular momentum. Is it okay till then? Now, read this sentence carefully. Angular momentum of the particle becomes the same as it was for t is equal to 0 at time t is. So, when t is equal to 0, because every term has t, hence when t becomes 0, angular momentum becomes equal to 0. This is equal to 50 alpha beta t square minus 100 alpha beta t square, that is minus 50 alpha beta t square, right, plus 500 alpha beta t plus 500 alpha beta t. From this what do we get? 500 alpha beta t is equal to 50 alpha beta t square. So, alpha beta gets cancelled, this gets cancelled 10 times, t gets cancelled in t square, t time. So, t is equal to 10. So, after 10 seconds, its angular momentum is equal to 0. At t is equal to 0 also angular momentum is equal to 0. So, that is the meaning. The angular momentum of the particle becomes the same as it was for t is equal to 0 at time t. So, you need to find out t. So, at 10 seconds and at 0 seconds, the angular momentum of the given body is same. Okay. Move on to the next problem. Look here, that is a direct question, because by using Pappus theorem we could derive the expression for the distance of center of mass of quadrant of a circular disc. So, here it is given like this. Out of this, what is given? Disc of mass m with uniform surface mass density as shown in the figure. The center of mass of the quarter disc from this point is asked. So, center of mass of the quarter disc, the x coordinate is given by 4r by 3 pi and y coordinate is given by, it is also given by 4r by 3 pi. So, here it is given xa by 3 pi, xa by 3 pi. So, in place of x we have 4. So, the numerical value is 4. Actually, that derivation we have seen in the class, isn't it? For a quadrant, when a circular disc is divided into 4 equal parts, then for each part distance of center, the position coordinates of center of mass from the center are given by 4r by 3 pi. The derivation we have already seen. Look into this problem. A force F is equal to 4I plus 3j plus 4k is applied on intersection at a point x is equal to 2 plane at x axis. So, the coordinate of this is at x is equal to 0, 2. So, y coordinate 0, z coordinate 0. That is, the force is applied on that point. The magnitude of the torque about this point. So, this is R2 bar and the origin is given as 2, 3, 4. You are supposed to find the magnitude of the torque. So, R bar is equal to R2 minus R1, 2 minus 2, 0, 3 minus 0, that is 3 J bar plus 4 K bar. And F bar is given as 4I plus 3J, 4I plus 3J plus 4K. F bar is given like that. So, the torque becomes R cross F, that is the determinant. I, J, K, here I coefficient is 0, J is 3, 4, this is 4, 3, 4, right. So, find out the torque here. So, I am finding out the determinant. I into 3 4s are 12 minus 12, I into 0 minus j into 4 4s are 16 minus j into 16 plus k into 0 into 3 is 0 minus 12. So, this is minus 16j minus 12k. So, you are supposed to find the magnitude. Magnitude is a root of 16 square plus 12 square, that is 256 plus 144, This is root 400, that is 20. So the numerical value is 20 here. That is the magnitude of the torque about that point. Okay, move on to the next problem. Last problem for today's class. This is based on law of conservation of angular momentum. A person of mass 80 kg is standing on the rim of a circular platform of mass 200 kg, which is rotating about the axis with an angular velocity 5 revolutions per minute. Okay, the person now starts moving towards the center of the platform. What will be the rotational speed, that is its angular velocity, when the person reaches the center of the disc? It is based on law of conservation of angular momentum. So here I1, moment of inertia of the disc about the central axis is mr square. Okay, plus actually this is the disc, and on the disc of mass m, radius r, at the edge a man of mass m is standing. So his moment of inertia about the central axis becomes mr square. With the man standing on the rim of the rotating platform, angular velocity is given as 5 rpm. When this man moves to the center, moment of inertia becomes, see here, moment of inertia of a disc is mr square by 2. Okay, because the man is now at the center, his distance is 0, hence moment of inertia is 0. Omega 2 is how much? That is the data we know. So here from law of conservation of momentum, I1 angular momentum, I1 omega 1 is I2 omega 2. I1 is mr square by 2 plus mr square into omega 1 is equal to mr square by 2, because only the circular disc moment of inertia, that is I2 omega 2. So we can take that r square as a common factor and cancel this. Mass of the disc is given as 200 kg. 200 by 2, that is 100. Mass of the man is given as 80 kg. Omega 1 is given as 5 rpm. 5 rpm. Mass 200 by 2, this is 100, omega 2. So this is 180 into 5 is equal to 100 omega 2. So omega 2 is equal to 180 into 5 by 100. Okay, so here 1 0 gets cancelled, 18 5s are 90, 90 by 10 is 9. So it moves with 9 rpm when the man moves to the center of the disc, right? I'll stop here for today. I'll continue with some more problems in the next session. Thank you and bye-bye.